Hey everybody, so in this video I'm going to run an example of limiting an excess reagent. We're first going to calculate what mass of the CO2 we could form based on these given values, these given masses of our two reactants. And then I'm going to add a little question to the end asking you guys how much of the excess reagent would be left over. So let's first find what's the limiting reagent and how much of CO2 we could form. So to begin with, if we have 25 grams of glucose, we want to convert these values right here into moles, because in stoichiometry we work with moles. So if we have 25 grams of glucose, how many moles would that be? Well, you could just, if you have 25 grams, and then you divide that by the molar mass, and the molar mass of glucose is 180 grams per mole. So if you divide that by 180, then that gives us, in the calculator, 0.1389 moles of glucose. Now let's see a potential of how many moles of CO2 it could form. Since the mole ratio of glucose to CO2 is 1 to 6, that means for every 1 mole of glucose, we could form 6 moles of CO2. So that means we could just multiply this number by 6, and that gives us how much we could potentially have of CO2 given this amount. So you multiply that by 6, and we could form 0.833 moles of CO2. Okay. Now we're going to compare that with the glucose. So this is the first one. So the second one, we have 40 grams of oxygen. Okay, we divide it by the molar mass of oxygen. In this case, it's O2 because it's a diatomic element, and that would give us 1.25 moles of O2, and it could form a potential of, let's see, what's the ratio between O2 and CO2? It's 6 to 6, which is the same, like a 1-to-1 ratio. It could form potentially 1.25 moles of O2. Now, what is the limiting reagent? The limiting reagent would be obviously the one that's smaller, because you could think of it as smaller material we have, and we have to work with that smaller material because there's no way you could make more material or more of a product that requires lots of material when you only have small material. So that is the amount of CO2 that we could form in moles. If you want to convert to grams, you just multiply by its molar mass, which is 44 grams per mole. So you multiply 44 by 0.833. So this we could just say is equivalent to 36.67 grams of CO2 formed. And now let's, this is the question that I want to add. How much of the excess reagent is left over? So if glucose was our limiting reagent, obviously then the other reactant, O2, is our excess reagent. So the excess, all right, we could set up a little proportion right here. If we were given 1.25 moles of oxygen, O2, and it formed 1.25 moles of, okay, I'm going to put oxygen here, it formed 1.25 moles of CO2, then that would be equal to how many moles of O2 were needed to make 0.833. Since you see here a 1-to-1 ratio, that means 0.833 moles of O2 were needed to complete this reaction given what was the limiting reagent. So that means we only ended up working with 0.833 moles of O2. But initially we were given 1.25. So what's left over? What's left over is what we were given minus what we ended up using. So you just subtract 1.25 minus 0.833, and that will give you 0.4167 moles of O2 that were in excess, or that were left over. And that's it.